So the first part here gives us points on the graph again. So our graph, actually, I'm going to change that a little bit. You'll be all right. 1, 2, 3, 4, 5, 6. All right, so we're going to graph those points on our graph. We have 0, 4, 2, 2, and 5, 6. All right, next set of information is giving us those critical values again. That's when the derivative is 0. So we're going to use those in our first derivative number line. All right, so here it says the derivative of f at 0 equals the derivative of f at 2 is equal to 0. So at both of these points, the derivative is 0. Then we're told when the derivative is positive and when the derivative is negative. So it's going to be positive it's going to be positive when x is less than 0 and when x is greater than 2. It's going to be negative when x is between 0 and 2. So what kind of a point do we have when x is 0? Maximum. And when x equals 2, we're going to have a minimum. So we know we're going to have a max over here. We're going to have a minimum here. And then the other point is neither. So good chance it'll be an inflection point, but to know for sure, we need to take a look at the second derivative. So the second derivative, we're going to make a number line for that using those last two lines of information. It says the second derivative is negative when x is less than 1. So I'm going to put 1 on my number line. And x is less than 1, it's going to be negative. And then between 3 and 5, it's going to be negative. Positive between 1 and 3, and when x is greater than 5. So again, here, each one of these, at each one of these x values, the second derivative is changing, so they're all going to be inflection points. And we already have one of them graphed right here. This one's going to be an inflection point. But we also have one at 1 and 3. So at 1, we need to figure out a point that's between the max and the min. Doesn't matter where you put it, somewhere in between there. And then at x equals 3, has to be between this minimum and this inflection point. So we can put it anywhere in between there. It can't be lower or higher than those 2 points, though. And our last part now is to go ahead and connect the dots using the concavity. Starting off, it's going to be concave down until we get to 1. So until we get to that point, the graph is concave down. It's going through a maximum, so it's going to be like a full U with that vertex going through the max. Then we're going from 1 to 3. It's going to be concave up. It's going to be opening up from here to the next inflection point. It goes through a minimum, so we're going to have a U. And then from 3 to 5, it's going to be concave down. We're not going through a minimum or a maximum, so it's only like half of an upside down U. So from here to here, just curving it, so it's opening down. And then the last part is concave up. And again, not going through a min or a max, so we're just looking at half of like a U or half of a parabola.